નમસ્કાર. આજના આ સંધાન કાર્યક્રમ અંતર્ગત જ્ઞાન મંચમાં આપ સૌનું સ્વાગત છે. વડીલોને પ્રણામ, મારા મિત્રોને યાદ તેમજ પ્યારા વિદ્યાર્થી મિત્રોનું ખાસ વેલકમ. મિત્રો, ઇલેક્ટ્રોનિક્સ વર્ડ સાંભળ્યો હશે. હવે આજે મારી સાથે જે મેઇન સ્ટાર સ્પીકર જે છે એ PRLના સિનિયર સાયન્ટિસ્ટ છે અને આપણે જે વસ્તુ વિશે વાત કરવાના છે, જે ટૉપિક છે એ છે સ્પેસ ઇલેક્ટ્રોનિક્સ. હવે ઇલેક્ટ્રોનિક્સ ઇઝ ઇલેક્ટ્રોનિક્સ, પણ વોટ ઇઝ સ્પેસ ઇલેક્ટ્રોનિક્સ એ આજે સમજવાનો પ્રયત્ન કરીશું. હું જો ઇન્ટ્રોડક્શન આપવા બેસીશ તો ડૉક્ટર મઝુમદારનું ઇન્ટ્રોડક્શન આપતા આપતા પૂરું 1 કલાક પૂરો થઈ જશે. તો બેટર કે એમનું ઇન્ટ્રોડક્શન પોતે જ આપશે. અને ડૉક્ટર મઝુમદાર, આપનું સ્વાગત છે. મિત્રોને
नमस्कार. मैं हिमांशु मजुमदार, मेरी एक्सपीरियंस का एक बड़ा हिस्सा फिज़िकल रिसर्च लेबोरेटरी USA में बिता, जिसमें मैं बहुत सारे स्पेस प्रोजेक्ट पे काम करने का सौभाग्य हुआ मुझे. फ़िलहाल मैं DDIT, DD यूनिवर्सिटी, धर्म सिंह देसाई यूनिवर्सिटी में रिसर्च विभाग का देख रेख करता हूँ. वहाँ हम कुछ स्पेस प्रोजेक्ट कर रहे हैं. मैं सोचा दिस विल बी गुड अपॉर्चुनिटी आपके साथ हमारी अनुसंधान शेयर करूँ. थैंक यू डॉक्टर लीना.
ઓકે, વેલકમ સર. હવે સર, આપણે વાત શરૂ કરીએ એ પહેલાં હું આપને જણાવવા માંગીશ કે આપણા જે વ્યુઅર્સ છે એ ફર્સ્ટ યર કોલેજથી લઈને તો રિસર્ચ ટેકના સ્ટુડન્ટ્સ છે. હવે એ લોકોને અત્યારે મેઇન રિસર્ચ શું ચાલી રહ્યું છે, એમાં મેઇનલી ઇલેક્ટ્રોનિક્સ અને સ્પેસ ઇલેક્ટ્રોનિક્સ શું છે એની આપણે બેઝિકથી શરૂ કરીશું.
ऑफ कोर्स.
ઓકે, તો શેલ વી સ્ટાર્ટ સર?
श्योर.
ઓકે.
डियर स्टूडेंट्स, आपको ये लगता होगा कि इलेक्ट्रॉनिक्स तो इलेक्ट्रॉनिक्स है, तो उसमें स्पेस इलेक्ट्रॉनिक्स में क्या खूबी है. सो लेट्स लुक एट द डिफरेंस बिटवीन इलेक्ट्रॉनिक्स एंड कंज्यूमर इलेक्ट्रॉनिक्स. कंज्यूमर इलेक्ट्रॉनिक यानी आप जो घर में रोज़ दररोज़ जो इक्विपमेंट, इलेक्ट्रॉनिक साधन यूज़ करते हैं उनमें, और जो इलेक्ट्रॉनिक्स हम डीप स्पेस में भेजते हैं अनुसंधान के लिए, दूसरे प्लैनेट्स में भेजते हैं, उनमें क्या फ़र्क है. तो इफ़ यू लुक एट ग्रॉसली, लेट्स लुक एट द स्लाइड्स. डॉक्टर लीना, यस. Now, the point is electronics and space electronics. If you look at the consumer electronics, the criteria, most of the important criteria is cost. So it is tried to reduce the cost by mass production. So one of the important characteristic of consumer electronics is it is low cost. And the reason it is low cost, of course, it has to compromise with its quality or some other attributes. So we'll see that. At the same time, for space electronics, we cannot afford smallest failure. A smallest failure could mean the failure of the whole mission, which may be multi-crore mission.
Yes,
so we don't compromise on price for quality. So normally most of the electronics which you will find which are sold space qualified or qualified for defense, they are all high priced components, and sometimes this ratio of the components, subsystems, could be 1:3 to 1:10 or 100, depending on the type of component you are choosing for the space qualified electronics. The second point is user friendly. The things which, like your mobile phone, radio receiver, television, they are extremely user friendly. It doesn't need literacy. It is icon driven, it is self understanding. So lot of research is being done on consumer electronics to make it user friendly. But in case of the space electronics, the most qualified people handle this. So this is custom designed and few of its types are made. So it is not as user friendly. It needs a lot of training to handle such components or subsystems especially. the low tolerance, the commercial component being low cost, its tolerance is low to environment. It cannot stand very high or low temperature. If you drop your mobile phone, perhaps it will become dead, it will not work. Whereas most electronic components or subsystems used in space electronics, they are deliberately dropped from a height to give a 10G shock, and they should survive. It undergoes through random vibration, minus 35, minus 27 degree to plus 120 degree centigrade temperature. Most electronic components should withstand. So its temperature, humidity, vibration tolerance is much higher than the consumer electronics. Consumer electronics has low life because of low quality and the production mechanism which uses to make this, whereas some of the space flight duration could be 7 to 10 years, and as a result these are designed so that each component is long life. In 10,000 components used in a mission, any one component failing with time perhaps will make the whole mission paralyzed. So long life is one of the important feature of space electronics. Low accuracy, because it is mass produced, there are no special, say for example your radio receiver, if it says that it is 55.50 megahertz, it need not be exactly that.
Yes.
You may have to tune it to get it. Whereas the space qualified subsystems, they are measured again and again and accuracy is maintained. The most important thing is the consumption. Most of the space electronics needs very low power. It has to be very low weight. It has to take minimum volume so that the resources are optimally used. But in case of commercial thing, we cannot afford to do such systems, and normally they consume much more current than space electronic does. Its volumes are much moderate in size. Weight is not a constraint most of the time, and that is one of the biggest difference between space qualified subsystem or component difference. Coming back to other few things, weight, size, mass, these are important features.
Yes, sir.
Now, if you look at the space qualified components, other attributes, what are the attributes? These are high reliability, as I told you, low power, and how to achieve low power we'll discuss perhaps as the lecture goes. Low weight, small size, it should be vibration tolerant, radiation tolerant. Once it goes outside, once your electronics goes outside the ionosphere protects us from external radiation. There are high energy particles continuously bombarded in space. So the electronics does get environment which is harsh, and these high energy particles could cause damage to tiny piece of integrated circuits. It should have high temperature tolerance, as we have said, and there are elaborate mechanisms to test high temperature, low temperature, radiation hardening. Most of the time the electronics which goes on board, they are hardened by radioactive protection. Now, the space electronic subsystem, if you see, what are these electronics we are talking about? There are different components, goes as a component, subsystem or system. And let's go through the list. The type of thing goes, the heart of the whole system is the power supply, and power is derived from space, which is a long duration. The battery life is not enough, So solar cells, solar panels are used. This solar panel in turn charges the chargeable cells. And these chargeable cells get power from solar panels. So solar cell is one of the important parameter component. Then rechargeable batteries, they are nickel cad and lithium ion batteries, which is high power density, are used in space flight. Then communication with the spacecraft is important, and it is done through transmitter and receiver modules. These are also tested for space qualification, and special space qualified modules are used.
Yes, sir.
For
સર એનો મતલબ એવો થાય કે whenever we are doing space research, we have to maintain electronic setup over Earth station as well as some mechanism must be there at a spacecraft
absolutely
for a
absolutely.
communication. Is
Communication.
it true, sir?
Yes, absolutely. You are absolutely right. But highest priority is given to onboard electronics, which
Yes,
has
sir.
to be, those are space electronics. At the same time, we can always have a redundancy in ground.
Yes, sir.
If one Earth station fails, a second Earth station could pick up immediately.
Immediately. Yes, sir.
Whereas you cannot afford that on board because you are limited by power, weight. So your system should be accurate and reliable.
Yes, sir.
So transmitter receiver are one of the major components which generates a link between your spacecraft and
Earth station.
Earth station. There are certain satellites which are not really communicating on their own. They are just transponders, repeaters, like your television.
Yes, sir.
So we transmit at a given frequency, the satellite receives, and it retransmits to a larger mass, larger audience at a different frequency. These are a combination of receiver and transmitter packed together. It is called transponders.
Transponders. Yes,
That's
sir.
right. Now, to make interface with this receiver and transmitter, you need a telemetry system, and which is nowadays digital telemetry. In earlier days, when used to fly from Tumba rocket station in early 70s, we used to have FM channels. Most of the channels had FM discriminators and they were analog. But now with time, most of the interface with transmitter receiver is digital in nature, and digital pulse code modulation technique is used, and they are digital telemetry system. And there are different standards again in the telemetry.
સર અહીં એક ક્વેશ્ચન પૂછવાનું મન થાય છે.
Sure.
જેમ કે ચંદ્રયાન 1માં પૂરી પેલોડ સિસ્ટમનું રિવ્યૂ આપે કરેલું, રિસન્ટમાં ચંદ્રયાન 2નું પણ સર આપે કર્યું છે. તો
Thank you.
અમારા મિત્રો જાણવા ઈચ્છશે કે આ બેમાં ડિફરન્સ શું છે અને નવું એડવાન્સમેન્ટ શું છે ચંદ્રયાન 1 એન્ડ ચંદ્રયાન 2.
Definitely, if time permits, definitely I have brought some slides, Dr. Leena. I will show you both the payloads on board Chandrayaan 1, what it achieved, what were the drawbacks, and how we will overcome them in Chandrayaan 2.
Okay.
Definitely, we will try to address that. Thanks for this. Now, quickly going through
Yes, sir.
the other components which are frequently used. Antennas are very important. They have to be directive, and because whole spacecraft is moving, orientation should be such that antenna points towards the Earth station. So this is also a challenging task. You have to have orientation of satellite. If it
Okay.
goes in a wrong direction, we will lose the communication with the spacecraft. Now, after this, these are housekeeping things. We need the actual experiment. The reason we send a spacecraft in deep space there are certain things we want to measure, we want to see, or from the space we want to see ourselves, our Earth.
Yes, sir.
For that, we need detectors and sensors.
Sensors. Of
Say, for example, what our remote sensing satellites are doing now at different frequencies, right from infrared to X-ray. They are observing our planet and other planets.
Yes, sir.
And this needs specific type of sensors, cameras. They're specially designed cameras which can look at 3D view of Earth resources at a different frequency band, and these are detectors and sensors. Some of the scientific detectors are very complex. They don't only look at the surface of a planet, but they can go inside the surface,
Yes.
like high energy cameras, hex cameras, which are used in Chandrayaan to see the subsurface of the moon, to find out the chemical composition of the moon surface. They are part of the detectors. This is beyond the scope of this lecture. Perhaps we will show you some of the slides which shows
Okay.
those beautiful equipments.
Yes, sir.
Then you need actuators. Actuators are the device which detaches the system. Say, for example, deployment of a solar cell, solar panel, or detachment of certain module from the spacecraft. They need actuator. Suppose I want to generate a shutter on my sensor, and this needs an actuator. Now, in most spacecraft, these actuators need to be specially taken care. Any mechanical movement, because most actuators are connected with the mechanical movement.
Yes, sir.
And earlier, we have seen in NASA and European space flight, most of the failure took place in tape recorders. Earlier days, we used to use tape recorders, mechanical devices, actuators. So these actuators we have to be very careful while using this actuator.